All right, let's talk about something really cool today. A huge breakthrough in how we teach artificial intelligence. I mean, forget just giving an AI a simple set of instructions. What if an AI could actually learn from its own experiences, its own wins and losses, to write its own ever-improving playbook for getting better at pretty much any task? This idea, as simple as it sounds, is shaking things up in a big way.
You know, it's one of the biggest questions in AI development. You've got this incredibly powerful model, but how do you actually help it adapt and improve over time? Especially without having to constantly retrain it from scratch, which, as you know, is unbelievably expensive and takes forever.
So, for the longest time, the go-to answer was pretty simple. Just give the AI a short summary of what to do. Think of it like a little cheat sheet. But this new approach, it's a completely different ballgame. Instead of a cheat sheet, we're helping the AI build its very own detailed playbook, one that actually grows and gets smarter over time.
Okay, so to really get why this whole playbook idea is such a big deal, we've got to first look at why the current methods are kind of falling short.
Right now, the gold standard is something called context adaptation. The idea is pretty straightforward. Instead of actually changing the AI's core programming, you just keep feeding it better instructions and examples right in its prompt. It's like giving a chef new recipe cards instead of sending them back to culinary school. It's super flexible, right? But, and this is a big but, it's got some serious hidden dangers.
And that right there brings us to the core problem, the whole reason we're talking about this. When you ask an AI to learn this way, by constantly updating its own instructions, things can go sideways, fast, like catastrophically wrong.
So researchers dug in, and they found these two, let's call them hidden dangers. First up is brevity bias. Imagine you're studying for a huge exam, and you keep making your notes shorter and shorter, until you've accidentally deleted the most important formulas you need. That's brevity bias. The AI, trying to be efficient, simplifies its instructions so much that it loses the vital details. But that second problem? Oh, that one's way more dramatic. It's called context collapse.
Seriously, just picture this. An AI has been working hard, learning a super complex skill, building up this massive library of knowledge. And then, poof, in a single moment, it's all gone. That is context collapse.
Okay, now look at this. This slide is wild because it shows you that failure happening in real time. Look at the graph. The AI's knowledge, which is measured in tokens, you can just think of them as little pieces of information. It's steadily climbing, up, to over 18,000. It's learning, it's getting smarter. But then, look at step 60. Bam, it just nosedives. All that knowledge vanishes, collapsing to just 122 tokens. I mean, its performance falls off a cliff. It actually becomes worse than if it had never learned anything at all. It's a complete and total system failure.
So how in the world do you fix something that broken? Well, this is where our hero enters the story, a new framework called Agentic Context Engineering, or ACE for short, and it's designed specifically to stop this kind of catastrophic forgetting.
And you know, the whole idea behind ACE is summed up perfectly in this quote from the researchers. They're basically saying, hey, let's stop thinking about instructions as these tiny, concise summaries. Let's start thinking of them as comprehensive, evolving playbooks that hold on to knowledge instead of throwing it away.
So what exactly is ACE? At its heart, it's a system that treats an AI's instructions not as some static cheat sheet, but as that living, breathing playbook we've been talking about. It has a structured process for adding new knowledge, fine-tuning old strategies, and organizing everything it learns. It's built to grow, not to collapse.
And the way it works is it's so smart. It's this simple three-step loop. First, you've got the generator AI. It tries to do a task and just records everything it did. Then, in comes the reflector AI, which is basically the coach. It looks at the performance and says, okay, here's what worked, here's what didn't, and here are the key lessons. And finally, the curator AI steps in. This is your editor. It takes those lessons and carefully weaves them into the playbook as new, concrete strategies. This loop, generate, reflect, curate, is the secret sauce. And this is what that playbook actually looks like in practice. This is so cool. It's not just some jumbled mess of text, right? It's all neatly organized. You've got sections for strategies and hard rules, useful code snippets, and even a troubleshooting and pitfalls guide. It's a legit, practical manual the AI can refer back to so it makes better decisions next time.
All right, so the theory sounds awesome, but the real question is, does it actually work? Let's see what happened when they put ACE to the test.
Yeah, the results are, well, they're pretty staggering. So on this really tough benchmark called App World, the old method, the previous champ,
called JIPA. It maxed out at about a 46% success rate. But ACE, the exact same AI model, jumped all the way up to almost 60%. That is a massive, massive leap in performance, just from changing the learning strategy.
But here's the real kicker. It's not just more accurate. It's also way, way faster at learning. ACE cut down the adaptation latency, which is just a fancy way of saying how long it takes the AI to learn something new, by nearly 87%. So think about that. You're getting much better results in a tiny fraction of the time.
And this right here is the mic drop moment, the ultimate proof. On the official App World leaderboard, an agent running on ACE with a smaller open-source model managed to climb the ranks and actually beat the top-ranked agent. And that top agent? It was powered by a much larger, much more expensive proprietary model. It really is a classic David versus Goliath story, showing that a smarter way of learning can beat raw size and power.
Okay, so let's pull back for a second. What does all this actually mean for the future of AI? Because this isn't just a tiny little tweak. It's a pretty fundamental shift in how we think about this stuff.
So, what are the big takeaways here? First, you get way more reliable agents. No more of that terrifying knowledge collapse, which means AI we can actually trust more. Second, it's just so much more efficient. AIs can learn and get better faster and for cheaper. Third, and this is huge, it's a major step towards AIs that can just continuously learn in the real world, without a human holding their hand the whole time. And finally, because the playbook is something you can actually read and understand, it opens the door for more responsible AI, where you could even tell it to unlearn a bad strategy.
And that really leaves us with a pretty mind-bending question to chew on. We've just seen how an AI can learn to write its own playbook for success, learning from every single move, every mistake, and every victory. So if it can do that, what's next?